Where you know how you do the big jump and then.
Okay, welcome to ITS 450. Let's get started. So, first of all, a few reminders. Currently, we are on week 5, and as you know, week 6 is next week. Therefore, on week 6, we will have our exam 1. So next Tuesday or Tuesday, right, a week from today, at this time from 6 to 7:40, you will have your first exam, exam 1. It'll be through this medium online. I will open a link at 6 o'clock and close it by 8 o'clock so that you have enough time to, answer your questions. That exam will be just a written exam. And I will do the practical exam of the Buffer Overflow 2 on a separate day. I'm hoping that if I see progress in these labs, I know some of you have already solved the Buffer Overflow lab. So, depending on where you are, by Thursday of this week, we might schedule the practical exam for Thursday of next week, but the written exam for sure is Tuesday of next week, so a week from today. It'll be a comprehensive exam. It'll cover everything that we have discussed from the beginning of the semester until pretty much Thursday, okay? And as you can expect, about 10 problems or questions, and then you'll have an opportunity to answer them in some way. I do hear the ringing, actually, and that's probably somebody that I need to mute. So let me see. And I think that took care of it. All right. Yeah. So I've muted the microphone now, and so that should be taken care of. So as I said, the key thing not to forget is please don't miss your exam next week. Okay. Yeah. Please don't miss your exam next week, 6 to 7:40. Then I'll keep the link open for an additional 20 minutes. And you can submit your homework assignment, 8 to 10 problems or questions. There's pretty much the standard type of written exam I've done with you guys. And then hopefully the Thursday of that week, week 6, we can do the practical exam, which will be, you will need your virtual machine for that. And I will provide some code and some hints and problems. And you'll just have one problem that you need to figure out related to, what we've discussed so far. So now that I've said that, as you know, usually the way that I present this class for software assurance is we do the classic C and C++ problems first, set UID, format string, buffer overflows. That sequence takes us basically all the way to the first exam on week 6. And then after that, we start with the second phase of the class, which is web security, okay? So today, I'm not really going to introduce any new topics. Instead, I'm just going to do a review of everything that we've covered so far, and also to introduce the new topic, which is web security. So I usually like to start, I'm not going to give you a new lab in web security this week because you're working on the Buffer Overflow lab, right? So, that one's a bit longer, but I expect everyone to be done with that by Thursday. And then I'll give you 1 week to submit it, so it would be due basically a week from Thursday, on the Thursday of week 6. Okay, so that's the plan there. However, even though I'm not going to assign the first lab in web security yet, I will start talking about this again. Now, you might think to yourself, well, you know, we were talking about C, C++, now we're going to talk about web. How is that related to software assurance? Well, remember, we are not talking about language-specific things. That's not the focus of the class. Instead, it's about the high-level software assurance, right? So, you know, you could have software assurance in Java or other areas, but we are only focusing on C, C++ because of its, you know, importance, really. It's extremely important to be aware of this and understand it. And then web security, because you guys, a lot of you work in web, you know, the internet is basically in the web. And so understanding these is essential. So the tools that we use every day, or the large companies that dominate the landscape, Netflix, Facebook, Google, you know, all these companies that dominate the landscape have their products online. And that means that they need to create web apps that are secure, right? So we're always hearing how Twitter got hacked just recently, like, you know, within the last year, I believe, right? And so that's what the focus will be now for the rest of the semester. You're done. So if you didn't like the C++ stuff, at least you can breathe a sigh of relief, because we are really pretty much done with it. With the main topics, we are now shifting gears to web. So if you like web development, you know, that's great. You know, this is what we're going to focus on. Now, as I've said many times, this class, you know, it's a 450 senior level class. It's not required for the class, but I usually expect students have taken ITS 362. So ITS 362, as you probably know, was JavaScript, jQuery, PHP, and MySQL. So you should know by now SQL, you know definitely JavaScript, you know jQuery, and PHP to some degree. Plus also in 362, you should have covered MVC, which is Model View Control, which is a type of a process for programming web development to be more efficient and so on. Ajax, you don't need to know for this one. So at least, you know, that's in 462 anyway, so you don't really need it for this class, really. I'm sure you need it for security, you just don't need it for this particular class. All right, now, I know most of you have taken 362. Every now and then we have some students that haven't taken 362. If you haven't taken 362, you know, we kind of leave it that way to give you the opportunity to take the class. Even if you don't have 362, other students have done it, right? Without having 362, just be aware you kind of have to put in a little bit more effort. And that's, you know, the idea that it won't slow you down in your graduation time. So that being said, I strongly recommend, I don't know if I put yeah, I didn't include it here, but I think it's in the syllabus. If I go to the syllabus, I put another book in there in the syllabus. So let me open up syllabus. Yeah, here it is. So can you guys see the syllabus right now? Are you seeing that?
Yeah.
Okay, great. So if you haven't taken 362, I strongly recommend that you get this book. It's very inexpensive. It's going to be a crash course in PHP and MVC. It's called Effortless E-commerce with PHP and MySQL by Larry Ullman. Just get the latest edition that he's got out. I think it's not very expensive. So certainly what we're going to be doing from now until the end of the semester will, a lot of it relate to this. So this is certainly a book. It's, you know, that you have time to read and you can follow along. You don't have to read everything right away. You can, you know, you can just catch up. For those of you that have already taken 362, you probably do not need to get this book. However, getting it is not a bad idea because it will help you out a lot with the term project. You know, some of the seed labs that we're going to be doing now are going to be discussed also in the Wenliang Du book under web security. And they're also MySQL, PHP, JavaScript. So both books are great. You guys already have this one probably to help you with the labs. This book will just basically help you with the term project. So usually when I've taught this class before, I've noticed that students that got this book and follow along as they were much more they were less stressed about the project. Okay, they were less stressed about the project. Let's just put it that way. So what we're going to do is very similar to what we did with C. We're now just going to explore, as you might imagine, several security-related issues that have to do with web software. So we're going to start with the classic example of SQL injections and PHP type of injections. Then we're going to look at same origin policy. Then we're going to look at JavaScript related types of problems like code injections in JavaScript, something called cross-site scripting, cross-site request forgeries, and so on. Okay, so we're going to explore a lot of these ideas, and they're just ideas related to the web development languages that we know and that give us all the power that they give us. Now, I want to stress that the basic idea hasn't changed. The basic idea in C++ was, when we did all the format string and, set UID and buffer overflow, it's the same ideas. Code injection, right? You're injecting the shell code into the memory. That's still happening here. And input validation, which is the solution, right? So that's still the same, whether it's web security or C++. The only thing that might be a little bit different is that in C, you're dealing with things like in raw memory of the computer, whereas in web security, you're not dealing with the raw memory anymore. You're dealing more with either the terminal, or you're dealing more with the SQL database in the background, or the browser and how we're manipulating the browser to obtain session IDs and so on, right? So that kind of thing. So that has changed a little bit. The fact that we're no longer in the raw memory, we're kind of in a more higher level space in the computer, but we are still the same principle. We're still going to be doing code injections, and we're still going to be doing input validation, right? And that's kind of the same. So that's really the same. And then the input of least privilege, right, that relates to set UID, that's still pretty much there. Where set UID basically says, relates to the principle of least privilege, because you don't want to have someone retain root privileges. You want their effective ID to become that of regular user. That's the same with in MySQL, right? If we're going to execute SQL injection of a delete, well, if that database account doesn't have delete privileges, I mean, it doesn't matter what injection you do, you will never delete that. All right, so a lot of the ideas are still pretty much the same, haven't changed. Just we're changing mediums from the C type of things in a very low level raw memory to a more higher level in web development languages that you're all familiar with: PHP, MySQL, jQuery, or JavaScript. As you can see in the title of the book, it actually says effortless e-commerce. So what we're going to do for the term project, so I usually actually start the sequence of web security motivating the term project, okay? So that you don't just see these labs as independent things, but that you actually see the labs as a set of things with one single purpose, which is really to build, secure and assure, software that is assured for quality and security in the web development landscape. The project will involve doing a e-commerce site or working with an e-commerce site. So that, that's kind of the thing that you want to secure the most, right? Because it's got credit card information. So we're going to explore a lot of those ideas. So let's talk a little bit about that. So anyway, before I get into it, are there any questions about anything that I have just said?
No, no questions for me.
So definitely, consider getting this book. I do recommend it. It will help you. Just get the latest edition of it. All right, so now let's go ahead. We're still on Brightspace, so let's take a look at okay. So we are here, Buffer Overflow, as I said. So today, I'm kind of shifting gears. You should be finishing this Buffer Overflow lab. If you're still having trouble with it, you definitely need to see me, because I've seen some students that have finished this already. So I just want to make sure everyone is on track. Then today, if you notice, here's the schedule for the next week as I'm planning it. Exam 1 next Tuesday, Buffer Overflow practical next Thursday. This Thursday, just work on the Buffer Overflow lab. This will be the last lab session that I give you to just work on that lab. Or if you're done with it, with Buffer Overflow, then you can start this, project files. Okay, so that's what I'm going to talk about today. So today, really, I just plan to do a review. So sorry, I plan to introduce web security and the project. And that way, I'm basically assigning you work. I'm assigning and explaining how you can get started with the term project, okay? So that way, if you're finished with Buffer Overflow Lab and you need something to do on Thursday, you can work on this. And then in the time that we have left today, I will just do a review of, I have some slides to wrap up, and that will be my last lecture on the C++ type of vulnerability. So just kind of wrap that up, that sequence. And you can ask any questions that you have. All right, so that being said, me having given you the plan, now let's get started with this. So project files, as you know, I'm using Brightspace, and it's just a little bit different how I'm doing things now just because of how this thing works. But I basically create modules in a sequence. So I had admin, assume information, and then I had set UID, format string, buffer overflow 1. Project files is today, next week is exam 1, then buffer overflow 2. And then hopefully once we're done with all of this, then we would start with, I think we do the SQL injection lab first. So that's the next thing that you can expect. And that's a very, students always like that lab. So I think you'll really enjoy it. It's one of the seed labs. It's really nice. But anyway, so let's get started with the project. All right, so if you look at the project files here, there's a lot of files in there. All right, so what are we gonna do? So you're going to build an e-commerce website. Now, when I say build, I'm misspeaking, because I give you, the scenario is this. The scenario is this. A company was developing an e-commerce website. They're a company that sells some product. They were building that e-commerce website, and before the e-commerce site was finished, the developer found another job and left. This is a very common thing that might happen. So they needed another developer. They were looking for one, and guess what? They hired you. All right, so now you come into this business and they say, well, this is what we have left. Here it is, of what the other developer did. So here's the other developer's code. Please finish it. Additionally to that, they're going to say, you know what? We were going to use an old Linux server that we had, but we just purchased a brand new one. So it can use 1604, 1804, whatever you want, 20, whatever the latest version is. And I leave that to you. So you guys will need to get first of all, a virtual machine. I suggest you don't use the CVM for this, because the CVM has a lot of pre-configured and pre-installed things. And it might just be better to use a brand new machine and build it yourself, okay? So that's one recommendation. So go ahead and get a VM that is 1604 or 1804. The reason why I wouldn't recommend 2004 or anything like that is because there might be less information about it on the web to troubleshoot problems. So you want to go with the things that have been there longer, that have all the bugs fixed, right? So that's one recommendation. Certainly you just need one. Another recommendation is try to use something like GitHub or some other tool to share the code, all right? You're gonna be working, I should say, this is a project that you will be working on in groups of 3. So form groups of 3, no more, no less, right? And you're gonna start coordinating. This project is worth 30% of your grade, so it's worth a lot. And it is a busy project, okay? It'll keep you very busy. You know, if you fall behind, you know, you might be, not be able to do something. So make sure you start working on it as soon as possible. The project is very nice. It's an e-commerce site, as I said. I would argue that it's more than 70% complete, maybe even 80% complete. The project was finished by the previous developer, and he or she was doing a really good job. It's just that they weren't able to finish, okay? And so now it's your responsibility to finish, but there's a lot of broken things. Things are broken, right? Because they weren't finished. And so given that this is a software assurance class, your goal will be to ensure the assurance of your software both in terms of quality and in terms of security, right? So remember, just because there's a broken link, okay, that's not a security issue, but it's still a quality issue. You don't want to have broken links. So you need to fix all of that. Does that make sense, guys? So it's not in 362, the project, when I've taught the class, students build a project from scratch. They literally build something from scratch. That's not what you're doing here. Don't even try it. I mean, you won't be able to. This is a very complex program or website, an e-commerce site with a lot of features, and you will not be able to build it from scratch. In fact, I don't want you to build it from scratch. I want you to use the code that I provided. If you look, the code is already there. It's called Ecom Scripts EX2. So you'll have to download that into your VM. You will have to configure that VM, Apache, to be a web server, right? And to basically serve the pages and everything. So you're building your web server in Apache. You're going to load this code, and then you got to make it work. Now, the code is not bad quality. It is actually really good quality code, but it is unfinished. So you have to, my goal for this is that you will audit the code. You will read all of the code, find all the bugs. Additionally, I may have intentionally gone into various places in the code and just left a few surprises in there for you. Okay, and so if you don't review this thoroughly, and I'm not going to tell you guys where the bugs might be, I'm just going to wait until the day of the presentation. So on the day of the presentations, I may just say, okay, you showed me all of this, but now go here. And I will know, because if you didn't fix it, if you didn't find it, it's going to break, right? So just be aware of that. The basic idea of the e-commerce site for everyone is that it's basically a warehouse that has some kind of physical product. It's not like digital, like a movie on Netflix or anything like that. It's actual, computer parts or tools. So that's the kind of website it is. Or for selling coffee or tea. It's got an inventory component that is for the employees of the company only, an internal side, and it's got an external side, which is the customer facing. So that's very much like Amazon. You go there, you shop, you add items into a cart. So it's going to have the idea of the cart. Now, one thing that it doesn't have is it doesn't have encryption, right? So it doesn't have, your certificate authority. It doesn't have your, symmetric, asymmetric encryption. You will have to do that yourself, okay? That's what, but you're an administrator. You will have access to your server. So you have to show that you did that correctly. The other thing it doesn't have is it doesn't have logins. So people have to, when they shop, they will have to, much like when you go to Amazon, you have to create, log in, create accounts, do that all securely. So that's hopefully a topic that you covered in 362, user account management, right? So that's, an important topic. You will be using MySQL, so MySQL and PHP MyAdmin, so you'll have to configure that on your server. And then basically just pay attention. Now, there's a lot of scripts in this folder structure because this website is written in MVC. So like I said, MVC is a topic again in 362, which is called model view control. And the idea with MVCs is, well, actually, who can tell me what's MVC? What's the idea there? What's the idea when you develop, let's say, a website using MVC? It's a type of an approach, right, for coding that has advantages. So what is it? Who can tell me? Nobody? I'm gonna pick on someone.
I honestly don't remember Professor Yang going over that with us when I was in 362.
Yeah, so MVC is, I'm sure it's probably the name that you don't remember, right? So MVC is this. You, instead of writing one single file, right, one single file that has all the code, you just divide the code into multiple files. So for instance, the header, that's one file, and it's just an HTML file. The footer, that's one file, it's just an HTML file. And then inside the body of the file is the PHP file that really just has a lot of include. So like you'll do include header, include SQL, here's the SQL query string, include footer. You know what I'm talking about now? Guys?
Yes.
Yes, right? So that's what I mean by MVC, okay? So, I'm sure, it's very easy to pick up. I mean, but just be aware, all the code, most code should be written like that. And so this code is no exception. The idea is, you have an HTML, right? HTML header. Header, HTML. So some of your labs will also be like this. And then you have like .php, and that's usually, the body, let's say. And then actually, let's call it, let's say this is just info. And then over here, you have the footer. Oops. Footer.html, and that's another file. So when you do this one, first of all, your scripts are much shorter, right? They're much shorter. So it makes it a lot easier. So for instance, you do include, header.html, right? And then over here, you have the include footer.html. And then over here, you have whatever code you want to have in there, PHP, code, and so on. What's the advantage of this? The advantage is that you have a second page called contacts.php. This one also can call this header and this footer. So now imagine you have 20 or 40 pages in your website, and your customer decides that they want to change the header. you don't have to go to 20 pages and change the header on 20 pages, right? You just change it on the header or the footer, and that's it. Make sense?
Yes.
Okay, great. So that's called MVC, and that's what you will, that's, you know, I stress this because this is how you will find the code in the project. All of it is written in a very strict MVC approach. There's a lot of files in there, and just be aware of that, okay? So that's one of the main ideas with this. All right. So let's go back to Brightspace then. Share. All right, so if we go to Brightspace then, the first thing you will do, as I said, start getting your VM. Then after that, you're gonna download the software. Now, I've provided this link here, Ecom Site Setup. It's a Word document file that will give you a few hints on how to set everything up. Now, you know, how to get my PHP My Admin. Now, you can also just Google it and find a lot of references on it, but I provided that just to kind of give you a quick overview. So it will provide some instructions on setting up MySQL. Also, when we do some of the labs, especially the SQL injection lab, that also has information about setting things up. So that will also be helpful. Additionally to that, there's other documents in here related to how to document the project. You're going to create a report, kind of let's think like a binder, let's describe it, of the whole e-commerce site, right? So, you know, you're going to create like the design specs and all the information. For that, you can start reading these documents. So SRS and these two IEEE documents, they will give you a lot of very valuable information on how to basically document a software project. All right, so that's really what I would like you to do, is to start reading those. And we don't have to do everything in there, you know, basically read them so that you get the idea of the why you do things, you know, for your approach. Additionally to that, I usually like in projects to just give a list of questions. So you can see that there for 50 questions. And what you're going to do there is you're going to I've posted there some questions related to various things. So have you done this? Did you do that? Did you address SQL injection? You know, so some of the questions are going to be more clear once we've done the labs, but they're just basically a series of questions that you need to make sure you have addressed, okay? There's some specs here about the project as well that you can read. And then additionally to that, there's just more documents on, you know, little specific aspects of the website, like email and things like that, okay? So certainly start looking, download all these documents, get the VM, download the code here, start reading through all the documents, form your groups of 3, and just get going with that. On Thursday, like I said, for those of you that have finished with the Buffer Overflow lab, you can go ahead and ask any questions that you have about problems with setting everything up. All right. Are there any questions about any of these files at this time? All right, seems like there's no questions. So let me now switch over to the whiteboard, and I just want to give you a little outline of the site, right? The site. So what does the site look like? So when you start to run it, you're going to see that it's got a main menu, right? So it's got a menu of products, and it's got a cart somewhere on here. And so when you go to the website, you can navigate through these, and you get lists of products with, like add to cart and quantity and all that. Then there's a checkout right in there. And so all that functionality is more or less working. However, you have the whole opportunity that once you get to the cart, you can check out. And the process for checkout has some intentional or some problems with it. So several things will break. Okay, so you will have to then, although the code is there are missing pieces or there are errors in there, and you just kind of have to fix it. Right? You have to provide assurance of it. You also have to make sure that things are secure. So for instance, there is no login just yet. You have to do that. All right? You'll have to do that in an appropriate way with the database and all of that. When you start the cart process, checkout process, sorry, and I will provide a lot more detail later on in the semester. I mean, in particular, checkout, I like to discuss that a little bit more because checkout is really one of your biggest challenges in this project will be checkout, getting that going. So in checkout, as you might imagine, you have your products, you hit checkout, then you have to put in your information. Then at some point you put in your credit card information, and then the credit card information we don't use PayPal in this project, but instead you're going to use what is called a credit card clearinghouse. And that's a third-party company that exists in the internet. In this case, we're going to use authorize.net. Now, authorize.net is a well-known credit card clearinghouse. There's many out there. This is the one we're using, and they will handle all the credit card transactions. So you basically will create an account on there as a developer, and then they're going to allow you to create like dummy accounts because usually you're developing first before you go live, so you need to test a lot of things. So they're going to give you some fake credit card numbers that you can use, and you'll be able to see transactions. Whenever you place an order, it should appear here, and then you should complete the whole checkout process. At the end, you need to generate an invoice. Whenever you buy something on Amazon, you feel that the transaction is complete when you get that email from Amazon, right? Confirming the product that you purchased. So you're going to do the same, generate an invoice and send it via email. Okay, to yourself, right? And so you need to solve all of that, all of those things. So sometimes the program will be interacting with services in the operating system. Sometimes it will be operating with external entities like a clearinghouse. With all of this, you need to provide SSL, right? So security. So you can nowadays usually web browsers secure the entire page, so everything is encrypted. So you will have to do that. This website, as it currently stands, some pages were made for encryption, some weren't, and so you will have to literally adapt to that, right? And just you can make it all SSL, but you need to make those changes in the project itself. Okay, once you check out, you get your everything, and then now there's an additional module in the background. Don't forget, there's actually a second. There's a second module, if you will, in the background, and that's going to be the inventory management. So the inventory management is like the warehouse of your company. That's where people will go to fulfill orders. So for instance, a customer placed an order here, and then now the person in the inventory management in the background needs to go into the warehouse and say, okay, here they ordered 3, we have 4 on inventory, we can fulfill the order, and boom, they check out the order that way and send it via the mail. All right, so you need to also make sure that this is working. What I can tell you is the inventory management is a little bit more complete than the sales part. In particular, there are bugs everywhere, but I can kind of hint that checkout is really the most problematic. So you really want to get started on this as soon as possible. Okay? As soon as possible. Just getting everything set up and reading the code, right? Reading the code will help you a lot. As I said, then, you know, one of the things that this is missing also is you need to add a module from scratch. There's one module in this that was not done, right? And it's a module for, you know, and we can vary this depending on your project to make it more interesting. But let's say it's a module for, you know, where users put in like a subscription to the magazine of this company. So then they have, you know, you have several text boxes in there. People have to put in their information, their address, etc. Save it to the database. And then when they hit something, it should give them some additional information. So that basically means, in short, that inputs that you provide on that module will be written and read from the database. So of course, given that you're writing that module from scratch, you have to make sure that you validate all inputs. So input validation will be critical here, right? So make sure that you do that. Plus, as I said, this is where all the labs that we're going to do, you know, some labs focus on JavaScript injection. So you need to make sure that I can't put, you know, one of the things I'm going to try to do in that module that you create is I'm going to ask you to write a JavaScript right there in that text box. You know, so just a for loop or something, and that should not work if you validated it properly. So, you know, I wouldn't say that any of this is difficult individually. What's difficult about it is that it's probably a lot, right? It's probably a lot, and a lot of it has to work well together. Is this clear so far, guys?
Yeah.
Great. So this is the project. I think it should be a very fun project for all of you. You know, I think you'll learn a lot from it, you know, because you're actually getting to build like a very, you know, what you could consider a very professional e-commerce site. One thing I'm going to ask every group to kind of pick a theme, okay? Pick a theme for your store, you know, so you can sell, you know, some, I think the main idea is that this, the one that you have sells coffee, right? Which is like the most boring product, but instead you can switch it to something else, right? So sell some other thing, like you can sell computer parts, you can sell, just as long as it's something physical, right? So sell tools, sell, you know, supermarket, you know, now, or find something related to, you know, the pandemic that's going on. So masks, you know, whatever. You could sell, I had one group that sold dirt. So all types of dirt. They were actually quite impressive in the amount of variations of dirt that they had. But, you know, you can pick something, you know, just something that you enjoy. At the end of the day, you know, it's the same idea, right? So we're, you know, you go to Amazon, you can buy just about anything. So that's kind of what you're doing. One recommendation I will make is this: don't go out and change the database. Remember, you're not building this from scratch. And if you start redesigning the database, nothing will work, right? So don't do that. That's certainly one thing. Instead, I would say adapt the database to whatever it is you're doing, but be very careful. For instance, like in the quantities that you start changing, oh, well, I'm selling, you know, I'm selling ice cream, so I'm going to put in scoops. And then, you know, that's going to complicate things because you're going to end up changing a lot of code. That's not what I'm asking you to do, right? It's not really about your skills in developing very great databases, okay? Not at all. Just secure the database, use the data. I would say literally use the database as is. But you will need to change the product. Now, what's so great about this is that the website actually sells two types of things. It sells things like coffee or tea, which have a specific type of quantity, right? You know, quantity of like pounds, that kind of thing. You sell by the pound. But it also sells mugs and I think books. And so because of that, you can emphasize more on this side or more on that side, but you have both types of tables in there for those types of databases. So you can kind of just modify it. I really don't, I'm not actually asking you to sell 1,000 products, right? You know, usually students sell 3, 4, and that's good enough. All right, so definitely a recommendation there. Don't change the database. It'll make your life a lot harder. Another idea is the directory structure. So the file structure that you have of where the files are located and what folders, I would say study that and understand it really well before you start making changes, because that's a common mistake that students make. They start moving things around and then nothing works. Again, the website does work really well. It's more than 85% complete. You just have to finish it. But sometimes it's not just about finish it, it's finish and provide assurance that it meets quality, nothing breaks, no broken links, and that you've addressed security, which pretty much will mean you know, input validation. At the end of the day, everything, you know, in this will, you know, kind of summarizes to input validation. Okay, so that's, I think that's enough. That's as much as I can give you for now of the term project. I don't remember, I don't know if I missed anything for now, but it certainly should be enough for you to get started. As I said, this Thursday, the plan is for us to focus on, for those of you that haven't finished, one last opportunity to finish the Buffer Overflow lab. You know, if you're having trouble, like, you know, last Thursday, you know, I stayed with some students and we solved some of their problems. So if you're at that point, you know, also bring your questions. For those of you that have finished the Buffer Overflow lab, start working on the project, and then just be aware next week we have our exams. All right, so remember, this is kind of the first introduction to the next sequence in this course, which is web security. Right? And I usually like to motivate all of it by starting with the project. Okay. Starting with the project. So please, I'll give you guys a few minutes right now, just you know, either through the chat or email or somehow form your groups of 3. Okay, form your groups of 3. I want to make sure everyone is started with that, and then after that, we will begin our final review of you know, the C++ related topics that we covered in this first sequence of the course. Okay, kind of a review to wrap up, and some new things, but take this time to form groups of 3, please. And if you have any questions, just a couple of minutes, and then we will get started with the slides. now more than ever, using GitHub might be a recommended thing, you know, given that all of you are in your homes and because of the whole social distancing, you probably want to spend some time also getting acquainted with GitHub and how you can post your code there so that your friends can share it and all of that, okay? All right, guys, so I think at this point, most of you had had enough time to form your groups. So let's, are there any questions about that before I get started with the slides? All right, seems like there's no questions. So then I'm going to share, I'm going to move on now to a review or a final, this is the last lecture related to C, C++, and kind of a review for the exam as well. All right. So you should now be seeing the slides that I have on here. All right, so this is, you know, just kind of wrapping up everything that we did and leading up to buffer overflow types of problems. Okay, so this is C, C++, course wrap up. All right. So as we know, the basic idea, here is memory, strings or arrays, buffers, right? However you want to call them. So strings are a fundamental concept, but they are not a built-in data type in C, C++, as we have seen. C string, C style string basically character arrays that terminate by the first null character. Okay. So there's a lot of libraries certainly in classes that you can use, but that's really the main idea. So you have, you know, a buffer of a specific length, and then you have a null character in there, and then you have the notion of a starting, the address that points to the beginning in memory, or, you know, a pointer of some kind. So C-style strings consist of a contiguous sequence of characters terminated by and including the null character. Okay, so a pointer to a string points to its initial character. The length of a string is the number of bytes preceding the null character, right? And the value of a string is the sequence of the values of the contained characters in order, right? So those are all kinds of things you already knew, but they kind of just motivate, you know, what we're doing, right? So we have a buffer in there in memory, and somebody is going to try to exploit that buffer in some way, leading up to the buffer overflow vulnerability. So here we're going to look at some common errors that you do when you have these types of buffers, right? And one of the things that we will explore in the rest of these slides is just these ideas. So common errors are unbounded string copies, right? So that was the main idea with the buffer overflow. We're taking something that's really long, right? And then we're copying it into a smaller space, right? So it's unbounded. We're doing a copy, but we're not really checking the size, and that's, you know, a problem. How do you solve that? You know, easily. Input validation, right? Input validation. But as we have seen in the labs, if you don't do that, you can have some really unexpected behavior. You can also have null termination errors, right? Because, you know, it just starts reading until it finds the null character. You also have other issues related to truncation. So when we fit, for instance, a variable that is larger into a variable that is smaller, what might happen is the data actually gets truncated. So even though you don't get a buffer overflow, you might get a loss of information, for instance. So writing outside array bounds is certainly a problem that we want to avoid. Other, you know, off by one errors, we'll see what those are, but you can have those as well, which is basically that, you know, you do a for loop, for instance, and you didn't terminate at 20, you terminate at 19 or 21, and therefore you are off by 1. So these are all common. Nothing here that I'm discussing is new, right? These are all things that you've come across at some point. It's just that now they are being placed in the context of security, right? And as we have seen, they could potentially lead to very serious problems, you know, like getting a root shell, which has been the goal of the, you know, of what you've been doing for the last 5 weeks. You just wanted to get, you know, that root shell, for instance. Okay. So strings. So what's, you know, basically what's wrong with them, right? So, you know, we're going to look at some examples of code, and I'll ask, you know, to make this a little bit more interactive, more fun. I mean, I'm just going to ask you guys to tell me, you know, what do you see that's wrong with this? Okay. You know, what's wrong with it? So here, for instance, we have a variable of size 80, and then we have the function gets, that gets something from the user. Now we're saying get an 8-character password, but what could be the potential problem here? What do you guys think?
You don't have anything blocking like odd characters and stuff. So
Okay.
it could.
Right, so you're not input validating, right? You're not input validating the characters, not limiting. Also, you could say that, you know, what's the size of this password that they're going to enter, right? Obviously, it's going to get maybe assigned to this one, but what you're reading from the terminal or the user supplied input could be much larger than 80. And if it's much larger than 80, you end up with the same problem where this this is 80, this is 180, and so you're going to then have a problem with that area there. It's the same kind of problem that we've been doing all semester. So here we can see gets, here the program reads from standard input until a new line character is read or an end of file condition is encountered. The programmer does not know the size of the input. So the problem is the buffer is not as big as the expected input, and so there might be what is called an unbounded string copy, which could result, depending on how you implement it, it's one of the building blocks of the buffer overflow. Make sense? All right.
Yep.
Looks like there's no questions, right? Let's take a look at this one. What about this one? What might be the problem here? You guys remember what argv1 and argv2 are? Whenever you're on the terminal, and let's say this program is called prog.exe, then after that you say some parameter here and then another parameter here. Usually these parameters go in there, okay? So they're called, they usually go into that argv parameter, and then you can reference them by doing argv and argv2. Okay, so it's almost like saying, whatever I read in argv1 goes there, goes there. So what might be the problem here? Notice you're doing a string copy and a string cat. So cat just for concatenate. So what might be the problem here, do you think? Anyone?
Is it the same? You're not like having any kind of input validation as far as like ARP1 and ARP2, like what they would be?
First of all, it's always input validation. So that's really the solution to everything. So that, that if I was to summarize this class in 2 words, input validation. So you're right. The other one is to pay attention to this one, right? So this name is 2048. But again, you're first of all copying argv1, right, into name, and then you're concatenating the other one. Now with an equal somewhere in there. Now what's the problem? This is 2048, but what's the size of this one? I mean, you can type a lot of characters on the terminal, right? So they could potentially, again, be greater than 2048. All right, good. So let's take a look at this one. What might be the problem here? Keep in mind, I will probably give you things like this on the exam, some examples like these of code, and just ask you what might be the problem. So what might be the problem here, you think? Because now you're solving it, right? How are you solving the previous problem here? Who can tell me?
By using malloc, I think.
Okay, what does malloc do in C? Malloc is a way to dynamically allocate space in memory. So what you're basically doing here is you're saying, you're gonna try to do that with the inputs, right? I'm way ahead of you. I'm gonna take your input. I'll take whatever that value is. Let's say it's 4,000. I don't care. And now I'm going to allocate a variable buff to be of that size, 4,000. So therefore, it's impossible to overwrite, right? Doesn't matter what they write. Every time before it's assigned to the variable, they look at the size and allocate dynamically the buffer. So it's always the appropriate size. Notice it even has a +1 in there for null characters or whatever. It's accounting for that. And so this should work well, right? But then what might be one potential problem with this? What could be one potential problem with that? In particular, imagine that the input is not provided by the terminal, but let's say read from a file or a stream of some kind.
Could the input be too large for the computer?
Exactly. Very good. That's a great answer. So, I mean, it's a possibility, right? That, you know, given the constraints that you have on the system, you might say, you know, I'm going to read it from a file, and I'm going to just overfill memory. And so in that case, that's a type of denial of service attack, right? Because you over exerted the memory. And so the computer was also. So there's always little tricks to things. Okay, so that, you know, that's kind of what I'm trying to stress here. All right. So in C++, they allow the same mistake, right? So here you're reading from, you have a buff of size 12, and you're kind of reading in, standard in, right? And you sort of end up with the same issue. Overflows buffer when input is longer than 11 characters. Cin extracts, and you can see that over there, Cin extracts, Cin extraction ends with a valid white space, a null character, or end of file. So it's a type of an unbounded string copy. Now, the solution to all of these things is input validation. And usually it's not very difficult, right? Notice, you just specify now some kind of a bounds check. Okay, that's it. So that's what I want to stress with a lot of what we're covering this semester, that now creating the code injections, that's difficult. I agree. You know, you guys figuring out the code injection for the buffer overflow lab or the format string lab or all of those was difficult. But preventing it is not that difficult because it's just a type of input validation. And we'll see that as well in the web security labs. You know, there's a similar idea as this one. Okay. So certainly the solution is not very complex. You see that there. Set the field width to a positive value. You know, if we do Cin with 12, limits the extraction of characters so that at most 12 characters, including the terminating null character, are read at a time. Right? So that's the idea there. Now, string truncation. Those, you know, sometimes you have functions that restrict the number of bytes. And that's recommended to mitigate against buffer overflow vulnerabilities. You know, it is recommended that sometimes you don't use, let's say, string copy, but use string n copy. You don't use gets, but use f gets. So sometimes it's as simple as that. Just switch to a better library, switch to a better set of functions, etc. If a string, now C does have this behavior sometimes, that when you have not just strings, but integers too, actually, all kinds of variables that exceed the specified limits can be truncated. And so it doesn't error out, but it corrupts the data. So truncation results in loss of data, and in some cases, it could result in even software vulnerabilities. Okay. What about this one? Let's take, you know, let's make this fun. Let's take a look at it. off by one errors. These are, these are kinds of things, when you were taking your C++ class, you probably did intuitively, you just know how to do it, right? So you have a source size 10, you have a string copy of characters, you have for loop there. So who can tell me just one error that might be there?
It's not starting at, it's not going to read the very first input of source because it starts at 0, not 1. So
That's
it's
right.
going to start at 1.
Right, and then it says until less than or equal to 11, right? So you have to take a look at all of those. So some nice special effects there. Right, so here we have, source is 10 byte long but gets 10 characters. The value returned by string length does not take 0 byte into account, hence destination is too small. For loop variable starts with 1, but string indices start with 0. The for loop stop condition is off. And the assignment at position 8 is going to be out of bound right. So that null character over here will not fit. And so, these are just simple off by one errors that we do all the time when we program. But in C, C++, they have bigger implications because you're so close to memory. So you have to just be a little bit more cognizant of that. So hopefully, the point of this class is that if you're ever if you ever work with C++ in your, you'll know that you need to be more watchful of things. Just like when we go over the web security labs, then you'll be more like, okay, now that I develop a website, I need to make sure that I've addressed these things, because in particular, if you don't do enough input validation, you can have serious problems, and you don't want that. All right. Okay. What about this one? What's the error there? Notice here, we're copying. We're literally copying, and we're not using string copy, string cat, anything like that. This is, a simple assignment, right? We're just assigning from one buffer to another. So it's not even that the functions are flawed. Look at this code, and someone tell me what you think might be the problem there, please. Any ideas? Come on, somebody try.
The length of argument 1 may be more than 128.
Can you say that again? I'm sorry.
ARG1, argument 1, the length may be more than 128, just the length of buffer.
Okay, yeah, that's true. So you're saying the input might be bigger than 128.
Yes.
That's true, but where exactly is the problem in this code? Like, where exactly would you say is the problem? I agree, but again, there's no string copy, right? Here, something else is happening. So what's the problem here that's allowing that copy to happen? Out of bounds copy.
Is it character asterisk arg1 equals argv1?
Which one? Sorry, say that again.
In main, the third line for while.
Not that one.
Cool. I don't know C++ at all.
Okay. All right. So if you look over here in this while loop, so in this while loop, there's that. What is that doing? It's reading the user supplied value, right? argv1, which gets assigned to arg1, so arg1. It's reading every single one, and it says read until what? Until it reaches a null character. And that's the stopping criteria. So really, if the input is really long, that null character is going to be at the very end, whereas buffer is of a limited size, let's say 128. So again, what do you end up doing? You end up overwriting over the bounds of your code. Right, guys?
Yes.
So
I think I understand.
yeah. I mean, yeah. So that's the idea. So the idea, well, if you say you think you understand, actually, then let me just rephrase that. So there's a while loop, and the while loop is reading arg1 is pointing to that, right? So when you're doing the while loop, you're reading all of these until you get to that null character. That's the stopping criteria, but that criteria is actually inconsistent with the fact that your buffer may only be 128. So it's going to keep reading and trying to copy into buffer, buff this one. Okay? So just be aware of that as well. So, as I've said before, the main problem with all of this is that, it's improper data sanitization, or, input validation is the more common word. Right? Because if you validate it, you just have to add an if statement in there. Check, an if statement. Are the characters that you just sent me, the length of it, is it less than 128? Otherwise, that's too big. So a much bigger problem, but here's a simple example. And this, you're kind of familiar with this because we've been doing this, would be if the user inputs, an application inputs an email address from a user, right? And it's making a call to this. What is this, do you think? When you see that bin mail, percentage, you should know all of this because you've taken 372 with me, right? So bin mail, the redirection parameter, and this is supposed to be provided by the user as an input, user input. What's the problem with that, or the danger? This is a system call, which is, we've talked about that quite extensively. We've said that a system call is nothing more than like thinking what you're typing on the terminal. So what's the risk? So again, I'll explain.
If the risk is if anything's inputted that it won't accept.
Right. So think about it this way. There's an application and it says, a little text box. Enter something there, your email. And then in the background, this is written in C, C++. It makes a system call. What is a system call? Calling the terminal. So literally, you're going to the terminal and you're going to run bin mail. Just like on the terminal, you type nano or you type sudo, right? That's pretty dangerous. And in particular here, if you remember from 372, you're doing a redirection of whatever is in there as an input to this mail. So here you have the opportunity to create a code injection. And I want to stress that this is what we will be doing going forward, is looking at these things, because Whereas before you had bin, you know, in the terminal, you had bin mail, right? And that's what you were supposed to run with, let's say, you know, Zach's user, right? And that, you know, you mail something. Now, the user controlled input has changed that to say bin mail to, you know, whatever. You don't even care, but you put a semicolon. And after the semicolon, in your input, you wrote cat etc. Well, you can see it down here. You wrote all of this. A second command, which will basically copy the password file and mail it to some bad guy, right? Because here you have a pipe, which is also, you know, like a redirection. Does this make sense, guys? So this is a type of code injection where you were expecting just an email from the input, but just like we did with shell code, now you craft this. This becomes your code injection, which if you're not careful, would run on the inside terminal of your operating system. Does this make sense? Are there any questions about it?
No, I think I got it.
Okay, so you got it, great. All right, so that's the idea, okay? And this is exactly like what we did in the Buffer Overflow lab. In the Buffer Overflow lab, you had the shell code for the terminal, you had to put it in the stack. So the stack was the place, the environment, and you just crafted that shell code. Here, the environment is through a text box, let's say, you make, from PHP, you could run commands on the terminal, for instance. It's not recommended, but you could. And so if you did something like that, somebody could craft an injection to kind of just, what you're doing is you're kind of like saying, oh, disregard this. I don't care about that, but I'm appending something here. And I in particular care about this, right? So that's really important that we are aware of how that works. But we will do more examples of this. Today is just kind of a wrap-up summarization of the concepts. Okay. All right, so let's keep going then. All right, so now we are going to focus, just kind of finalize our discussion of the Buffer Overflow lab. Summarize the ideas. Hopefully by now all of this is pretty clear in your heads, and you know it should just come easily. All right, so a buffer overflow occurs when data is written outside of the boundaries of the memory allocated to a particular data structure. So we've talked about this in the stack, right? And you have 11 bytes of data over there. And now, you know, I'm sorry, the stack would be actually that one. So this is the source, the input, user provided input. Notice that you were only supposed to use 8 bytes, but you ended up overwriting, right? And that's, you know, been explaining this for a couple of weeks now. So that's really the central idea. So buffer overflow occurs because we usually do not check bounds, right? If we just check, you know, limit the size of things. That's why, you know, and we'll see this when we start talking about web security. Whenever a user does not need to provide an input, make it a drop down or something. But it is highly recommended that you limit the number of inputs. Whenever a user can type any text on that text box, it is just an invitation to problems. Okay? Standard library functions do not check bounds, so, and programmers do not check bounds. So now, not all buffer overflows can be exploitable. So hopefully that was clear when we were just crashing the program, right? So a lot of the time we were just getting that segmentation fault, right? Seg-V. And so we didn't really, you know, we didn't really exploit the program, but certainly it was a quality issue. It was breaking, and you don't want that. Certainly, if it's a system, a computer system with an airplane, you don't even want that to happen because you don't know what, you know, what the result could be. So the idea is not to use these unsafe routines, like string copy. We've seen a lot of examples of that. There's a lot of libraries that have been optimized nowadays. So you want to avoid, you want to use things that help you, that in particular do input validation and so on. All right, so the buffer overflow, a very common attack mechanism, right? That's why, it's widely studied. You can't have a software assurance class without talking about it because it's still there and it's been there since the beginning. As you know, CC++, I think I've mentioned this many times, is widely used, very powerful, because that's the only way that you can really achieve high performance in your programs, right? You want your programs to be really fast and efficient, but it's a much harder language to master. And so it's been there since the 50s. I love the fact that C and C++, I like this. I have like a criticism of programming languages or libraries. I love the fact that C++ was invented in the 60s almost, I think, at Bell Labs. And SQL has also been around. I think in the 70s, they laid out, Peter Chen and some other people laid out those ideas. And those languages, if you think about them, have been around for 50 years easily, both of them. And we've had C and C++ over 50 years. So they don't change so drastically. They are, like evolving, but, the same Python, we had Python 2.7 and then it changed to 3. But it's always pretty consistent. But there are other languages, especially in the beginning, that change so much, right? So they go from being one way to being a completely different way. And so I have a personal like critique about that, about those languages. And I really like languages that, are designed really well and stay consistent, even though they can evolve, and they should. But anyway, that's just me, pet peeve that I have. All right, so anyway, so buffer overflow. It's a very common attack, been around for a long time. The prevention techniques are known, but it's still a major concern, right? And it's just because you have so much power, so much flexibility with C++ that, it's just harder to master. Now, there is some legacy code, but just be aware that still today, I mean, you can develop new applications with C++. I mean, so I wouldn't really use that term legacy. But basically that when you develop something in hardware, you want it to be efficient, and C++ gives you that. The other bigger problem is it's not so much carelessness, but it's just, humans make mistakes, okay? That's the problem. If computer programs were built by perfect beings, then they would have no mistakes. But computer programs are made by humans, people that work in companies that they want their thing in the market before it's finished, right? So Microsoft was the one that actually like perfected this strategy, right? They would build something, it was kind of working well, they would release it into the market. I don't know if you remember looking at maybe old videos of Microsoft in the 90s and early 2000s. That was their model. That was their business model. And that's why they created updates, because they just said, release it now because we need to sell. It's got bugs. We'll catch it in the updates phase. And they've gotten much better about that. But they used to do presentations where they would get the blue screen of death, right? They would, so it wasn't that the programmers were necessarily careless, but it's just the fact that the business drives everything. Money, people get paid the great programmers get paid the great salaries that they get, but they have a lot of work to do. And sometimes the constraints are crazy. And you will see as part of the project, that brings me to part of the project this semester, your e-commerce site, I want to stress that it's not a 100% coding project. In fact, you should dedicate, out of the total time in this project, you should dedicate a lot of it to just testing and then coding. I would say maybe 60 to 40% of the time in this e-commerce site, you should just do testing. That means using it. We're going to learn later in the semester something called white box testing and black box testing, right? And you really, I will show you what I want you to do, but basically I want you to fill out these templates of a lot of testing that you will do on the code of different scenarios. In reality, what happens? This line of coding goes in that direction. So you end up in reality with little to no coding, especially in startups. That will probably be very common, right? In a startup, you really just have very little time for that. You have to meet deadlines. The product has to be out, and if you have this whole updates scheme, we'll just catch it in the updates. However, the life cycle does stress that you should have a little bit more testing. I will do the same for you guys in the project. I'm saying do 40% testing. Students always forget this. They only focus on coding. That's why as part of the project, I make it required that you need to provide these testing templates. You will need to show me in your report that you've done all that testing, just to kind of drive the point, really, that you should try to do it. Does that make sense, guys?
Yeah.
Okay, great. All right, good. So here's some history of attacks, so you can skip that. Here's a formal definition of it: a condition at an interface under which more input can be placed into a buffer or data holding area than the capacity allocated, overriding other information. Attackers exploit such a condition to crash a system or to insert specially crafted code that allows them to gain control of the system. Perfectly worded. That's exactly what you're doing, you've been trying to do in your labs, and that's currently what some of you have already completed and others are working on for this Buffer Overflow 1 lab. Okay. Okay, so are there any questions at this time, guys?
No, I don't think so.
No questions? All right. All right, so how many slides do we have left? Let's see, we have Buffer Overflow Basics, which is now getting into the specifics of Buffer Overflow. So we've talked a lot about this, right? So I don't need to say it again, given that I've explained quite a bit of it. So we talked about, the basics of it. We talked about the memory extensively, stack. We talked about the goals. We talked about the difference between high-level languages and lower-level languages. We talked about that. Talked about the stack. So, you can read through these slides, but we've talked about all of this. Stack overflow, we talked about that. Defenses, as you know, one of them is address randomization, which is part of your lab. We have compile time defenses that check, basically. So you have additional code that is executed to run a time to impose checks. So that's basically what it is, right? So as you know, for the lab, we do like fno stack protection and all of that. That's basically disabling all of those things. Okay, so that's that idea. Yeah, so the problem with C is that there's much emphasis on space, efficiency, and performance instead of safety. And so but the fact that you have so many variables and that you're allocating memory really efficiently sometimes results in problems. Basically, just the recommendation here is use better libraries whenever you're programming in C, C++. We talked about stack protection. So you can see a description of that. Sometimes stack protection might be the fact that you have the stack, and in the space in the stack, you place a variable, a value. So what happens is the operating system is checking that value constantly. If somebody overwrote something, it'll, before executing, it'll check that value. If that value has changed to something else, it'll basically raise an error. Obviously, the problem with that is that it can make your code, slower, less efficient. All right. So we talked about that. Randomization is part of your lab. So basically, you randomize all the addresses in the stack where you're placing information in the stack. But even that can be bypassed, and that's one of the issues in your lab. That's one of the things I will address this Thursday is address randomization in the lab. How we can bypass that, and it's basically pretty simple. Just do a brute force attack. So we talked about this. We've talked about this code. You can take a look at this example, but it's pretty much what we've covered in lab. Just trying to see if I missed anything. So this is just the review. Here again, things that we've covered about how do we insert values into the stack, the registers, etc. You can take a look at that. That's an additional explanation. I would pay attention actually to this. Pay close attention to this because the Buffer Overflow 2 lab, your practical exam, might be a little bit more similar to that. Instead of writing the data from a text file, I'm going to ask you to actually only use the terminal to inject your code. Notice here, they're injecting A, B, C, D, a sequence of characters to kind of see that in the stack and figure out where things are being placed. And then also notice here, they are injecting something in particular. So definitely read through this example because it might help you a little bit more for the practical exam. Okay. All right, yeah, so we're going to stop here with this. I might go back to some of these ideas on Thursday. I do recommend for the practical exam, go through this example, okay? Go through that example a little bit, in particular, this idea here and that in particular, okay? Because, as I said, the exam won't be injecting from a file, but injecting directly from the terminal. All right, so that's kind of a review of everything that we've done so far this semester. On Thursday, wrap up loose ends from the Buffer Overflow lab. And then, for those of you done with it, maybe practice more, prepare for the exams next week. If you feel you've got it down, you can start working on your term project. Next Tuesday, exam 1. And hopefully Thursday, I'm shooting for the practical, but I still want to get some feedback from you guys on where you are on Thursday. All right? So I'll stay for a couple of minutes if you have any questions. Otherwise, we'll stop here for today, and I will see you guys Thursday. Have a good day.
Bye, Professor. Have a nice night.
You too.